So very warm welcome to everyone. Who's that? Sorry? Yeah. Can you all hear me now? Okay. That's wonderful. Try to speak from time to time, and if you can show me your video so I can actually see you. That for me that makes a big difference. You want to see me as well, right? So I'm right here. Um, and I feel like it's closer to a real classroom environment if I was actually able to see you as well. Okay. Uh, so let me just start today. This tutorial file is I will put it online. There aren't actually too many changes from last week because what I would like to do is I would like to go through especially Bodhi chapter 6, if not part of chapter 7, and I want to do it, you know, I want to take my time and do it with some quality instead of just rushing through it, because chapter 6 is important. Now, when we started this course, we recommended that you do some questions for chapters 2 and 3 and 4, and some of those were just for your general knowledge. But we have now got to a point where these chapters actually they are being taught by Professor Fong. So I think these questions you definitely should look at it quite seriously. And I'm going to have a look at chapter 6 now. I think actually for me, chapter 6, 7, and 8 are the more difficult ones. So if you look at this course, and if this was time and this is difficulty, I think it kind of started like this and it's going to go like that. Where is this point? This point is chapter 8, the single index model, which I think you were, Professor Fong was covering that yesterday. Is that right? Did he do that? I'm sorry I couldn't be with you yesterday. I had some prior engagement. So what can someone tell me what happened yesterday in class? Okay, okay, that's good. Um, did he started talking about a single index model? Okay, yeah, I think that was his plan. So I'm now going to do that. And if you were look, if you were trying to do these assignment questions for chapter 6 and 7 last week and you were not able to, that's fine. I think we'll give you one more week to handle that. Uh, now, just hold on 1 second. Um, so I have a few housekeeping things just to communicate to you. So the first thing is the assignment answers for the weekly assignments. When you click on this link, you will find uh, I have a file where I put all the answers. I cannot give it to you over here because it will be a breach of copyright. So I put them in a file, and that file will keep growing and growing and growing. Every week after we've gone through some solutions, I will put them in there and share with you. So even if I was unable to go through a question, and it probably is not an essential question, you can still refer to the answers if you need to. Okay. Okay. Now, uh, just by way of housekeeping, so this is our schedule, and I want to let you know because last week there was some disruption for the lecture last week. If some of you could not make it, you probably noticed that Plato and Professor Fong were trying to do a video recording. I have now edited the segments and put it together as one video, and you will find that video actually in Blackboard. So if you want to review the lecture of last week, now I didn't put it on YouTube because I don't know if Professor Fong would like it. So that video is in Blackboard. If you go in there, you will find it, the video of the lecture. As for our tutorial, our online tutorial last week, I also kept a record of that. And if you simply click on this link, this is a hyperlink. This will take you to a YouTube page. Okay, now I don't mind putting my stuff on YouTube, but I can't do that for other people. Okay. So likewise, I am now recording myself, and later on today, I'm going to put today's session in YouTube as well, and you can click on that if you need to. There is, I don't know, unfortunately or fortunately, I wasn't going to have a tutorial next week. I'm not actually here next week, so I haven't seen you for a little while. Or I won't be seeing you for a little while. Next week, it will be again Plato looking after you. Now, talking about housekeeping, so I understand that it will now become, I mean, don't scan on that QR code yet. It will now become impossible for us to meet on Saturday evening, and that really bothers me because I think there is a lot of value in us spending time together. Even if it's a short time, I want to talk to you guys every week for an hour or less. There are things that are really worth communicating, and now I'm not able to do it face to face. I have three proposals I would like to put to you. The first one is we meet for a short time. This is going to be heavy. I'll be honest with you, okay? I'll be quite open because that will cut your lunchtime from an hour and a half into 45 minutes, and my lunchtime as well. So that's proposal number one. Proposal number two, I'm happy to come in on Sunday, but I cannot make the same assumption for you. Maybe you're not. And if you don't want to, that is absolutely fine. I understand some people, you have engagements, your Sunday is valuable. Some people live very far away. Um, and then the last one is if we just do what we are what we are now doing, continue. So if you hold on, someone's knocking on the door. Okay. If you in your leisure time in the next couple of days, you just click on this QR code. It takes you to a form, and the form contains these three options, and you just pick which is the one that you prefer, and then I will have an idea what people would like to do. Okay, now these three options, none of them is perfect. Saturday afternoon, we only get to meet 45 minutes. That's not good. Asking you to come in on a Sunday morning, that's not good to campus. and then doing it the way we are now doing, that's not perfect either. But I am trying to do my best, and I hope you understand that none of these choices actually is perfect. Is that okay with everyone? Okay, so later on you just click on that. Now, regarding the presentations, I have a couple of things to say. The first thing is there is a little link at the bottom of the page, and when you click on that, it will take you to a Google Sheet, not Google Form, Google Sheet, which has your details, your project team, and the stock you're working on, and your position. Can you please, in your own time, try to fill in the entry price? And that price should have been the closing price, as we mentioned, of last Friday. So Friday afternoon, if you're working on a Hong Kong stock, and Saturday morning, if you're working on an American stock. If you are able to do that, then I will go in there and check it. If every team does a little bit, then it saves me having to do something 8 times. Okay. Is that okay with everyone? Thank you very much. Now, was that this was Yu Zhou, right? Good morning. Good morning. How are you? Yeah, well, I can't see anybody. I feel like I do that every week. I will go crazy. I will lose my mind. Talking in a room all by myself. Um, but anyway, um, Yujo, while I have you there, um, can you give me a number, a random number from 4 to 8? So 4, 5, 6, 7, 8. Just pick a number. 7. Lucky number 7. Okay, now the reason I'm doing that is so next week, Seeking Alpha, Team Seeking Alpha, and Team Doc, our PhD friends, will be presenting on October 19. Is there anyone from the Team Seeking Alpha here? Good morning, Xiaorong. How are you? Okay. Yeah. So you do know that you will be presenting next week, right? Okay, wonderful. How about the team Doc? Anyone from that team here? Maybe not. Now, um, the week after, one of the teams that will be presenting is a Teacup in Storm. I like that team name. Is there anyone from that team? Okay, Billy. Good morning, Billy. Now, I am going to thank you. I'm going to tell you which will be the other team presenting, because just now I asked Yu Zhou to pick a number, and she picked number 7. And in fact, I have just hold on 1 second now. As you can see here, these are your teams, and all the numbers actually are all scrambled up. And she picked 7, which is diamonds are forever. So congratulations, guys. So you are the proud winner today of the random draw. Diamonds are forever. Anyone from that team in the chat room? Okay, is that Qianyo? Okay, is it okay? You guys will be presenting on the 26th of October. Okay. Um, if you have problems, please do let me know. But we, as you can see, we don't really have a lot of window for swapping and rearranging, but we will try. Um, just a couple of things to let you know. First of all, the reason we are doing a random draw like this is that I think this is a fairer a fairer way of doing things so that everyone will get 2 weeks to prepare. Um, you've already done most of the work, which is your report and your PowerPoint. So the presentation really is just, standing up and then thinking of what to say. So, but the most of the work is already done. So we do this on a rolling basis. We do a random draw every week. That's point number one. Point number two, we are thinking of keeping a video record of your presentations. And I would like to emphasize that this will not be shared with anybody except your own team. It will not go on YouTube, nothing. So we actually want you to, because in my experience, I find that when I look at myself and I look at how I'm presenting, it makes a big difference. And people can really improve on their techniques, presentation skills. That's the reason we're doing it. Okay, is everyone okay with that? Yeah. Okay. Yeah. Thank you. All right. Now let me then. I think that's about it for the housekeeping. So first of all, scan on this QR code and let me know what you would like to do with the tutorials. First thing, and please try and do that within the next 2 or 3 days. And then please enter the prices, the entry price, okay, for your stock. Let me and then everyone should actually talk in the presentation, as we have mentioned. Keith says, I'm sorry, I don't have a mic and a webcam. Okay, no problem, that's fine. If you do, I would love to be able to see you guys. Okay. Now, I'm going to just quickly go through Bodhi chapter 6 for today. And I think these problems actually are very useful. And in the final exam, I think some problems would have a similarity to what you are seeing here. And I hear some kids' voice in the background. First, I'm going to go through problem 23. So problems 23 to 26 are based on this simple statement here, which says that, so imagine you are a fund manager and you have a client and the risk-free rate out there is 5%. And the client's borrowing rate is not 5%, it's 9%. So there's a 4% gap. And if the S&P 500 has an expected return of 13 and a standard deviation, otherwise known as sigma, of 25, and your fund looks like this, so the expected return of your fund is lower. Uh, if you are talking to amateurs, people who are not finance professionals or investment professionals, immediately their reaction would be, oh yeah, your fund only returns 11, whereas the S&P 500 gives you 13. Well, that's not the whole story, because you have to look at the risk. And this, I guess, has to be one of the key messages of this course. So it's not just about return. You can get any return you like if you're going to take an enormous amount of risk. And so let's take a look at this. So problem 23. Draw a diagram of your client's capital market line accounting for the higher borrowing rate, and superimpose on it two sets of indifference curves, one for a client who would choose to borrow and one who will invest in both the index fund and a money market fund. Okay. Now, there are only three things you can do. If you have $100, let's say you have $100, so you invest that $100 and then you actually borrow even more. That is a scenario we are discussing here. Scenario choice number 2 is you simply invest $100. Choice number 3 is you invest, I don't know, 75, and then the other 25 you lend out. And that is what they mean by investing both in the index fund and a money market fund. That's what that means. So having part of the money in the market portfolio and part of the money in cash. Okay. So in case some people are wondering, what does it mean have some money in money market fund? That means you just earn the risk-free rate, 5%. The answer looks something like this. Sorry about the scribbles. In fact, let me just, okay. I'm gonna rub it out so it's easier for you to see. And then I will give you the page with all the scribbles, which sometimes is useful. Okay, so you have, I don't know if you guys are familiar with the idea of indifference curves, but if you need help, please let me know. So this is the original capital market line. Now, capital market line, okay, first of all, is just something you plot on a graph that relates the return of an investment to the standard deviation, not the variance, the standard deviation. Okay, so intuitively, it should go in the northeastern direction. So the higher the return, the higher the risk. Okay. As Plato likes to say. And for the original, the one without leverage, you really only need 2 points. Point number 1 is when there is no risk and you get the risk-free rate 5%. Point number 2 is the actual portfolio for the market where you have a 25% sigma and a 13% return, which is what that was described here. 13% return, 25% standard deviation. So first we are dealing with the market, just the standard index portfolio. Now the problem is, and I think this is actually this is a good reflection of reality. When you are lending money, you are lending at 5%. So your capital market line goes from this point and it comes down here like this. But if you want to borrow, you don't have the privilege of borrowing at 5%. No, you don't. You have to borrow at 9%. So it is as if, it would be as if the entire capital market line is actually like this. But that's not actually true, because if you are lending money, it is this one. But if you are borrowing money, it is this one. That is why the capital market line looks like this, and suddenly it changes direction. Okay. Is everyone okay with that? I want to make sure that this concept is okay with everyone. Anyone has a question on this? Okay. Now, then the idea is that you need to draw some indifference curves to these lines. Now, the first thing to remember is that somebody who is more risk averse, someone who doesn't really like to take a lot of risk, um, which side of the investment, this side or this side? If you are risk averse, are you more likely to choose A or B? Which one? A is this side and B is this side. If you are risk averse, which sector are you more likely to land on? Okay, thank you. Um, Now, if you are risk averse, obviously you are not going to borrow money to invest more. There is the word for that is leverage. So you're not going to do that. In fact, you're not even going to be here. You will be somewhere along the line. And if you are maximum risk averse, you will be right here. You have no investments. Um, and it is actually possible to relate that to indifference curves. Now, if this is the indifference curve for individual A, so their indifference curves would look like this. So of course they would always prefer higher return for, for the same amount of risk. Everyone would, but you can't get it until you actually come down and there is a line that is actually touching the capital market line. And for someone like that, this will be the point where they would want to invest. Okay, because they are actually, for all the indifference curves that they have, only this one is actually touching the line at this particular point. So that's how it works. Now, if you compare two individuals, maybe I'll do it here. I'll do it here. So here is on the x-axis the risk, and then on the y-axis the required return. Now, if this is individual A, let's say this is individual A, So this is A, and this is individual B. If I ask you, so these are two different persons, A and B. So A obviously has some degree of risk aversion. And B as well. So if you were to compare the risk aversion of A and B, which person is more risk averse, do you think? A. Who said A? Is that Xiaolong? I don't know who spoke just now. Was it okay? Thank you, Xiaolong. By the way, I'm going to give you some participation points for talking. Why do you think it's A? That's right. You can see that the key to it is as the risk that what you said is true. For the same risk, they want more return. And as the risk increases, A becomes far more sensitive. So A is really getting nervous. And so taking that point and coming back here, so I was asking you if this is A, area A and B. So this person uh, over here is a lot less risk averse. Now, if you were to extend their indifference curves, I know it's kind of hard, but if you extend them all the way out here, this is exactly what you are seeing between the indifference curves of A, which go up quite fast, and the indifference curves of B. I mean, they are going up, but slowly. So B is a lot more relaxed with the required return, even as the risk is increasing. Okay, so I hope you can get that point, and that's why I was trying to draw in the previous. Uh, I had a lot of annotations here, and I was trying to draw a whole set of indifference curves between these two A person and B person. All right. Um, Now, um, problem 24. What is a range of risk aversion for which a client will neither borrow nor lend? That is, when y is equal to 1. Uh, that's question 24. And for 25, it's just a repeat of 23 and 24, but we are now not using the market fund, but using your fund. And then 26 is an interesting one. So they're asking if your fund um, if there is a lot of background noise, I can actually mute the people. Uh, Hold on a second. Okay, I have turned off the sound for everybody except myself. Can you still hear me? Just type a yes if you can. Okay, thank you. And if I ask a question, then I will unmute everybody, and then you can respond. Okay, that might be better. So you're not getting the background noise anymore, right? Now, what I want to do on this question is, so question 26 involves an additional element that maybe we haven't thought about so far, which is if you are running your own fund, then obviously you want to charge the clients a fee. But there will come a point when their behavior starts to change because of that fee that you are charging them. And we're going to see that in a moment. Okay. But first of all, let's have a look at question 24. Now, for that, you have to, now this is quite important, and I guess it's good we have time, we can spend time here in the tutorial. I would recommend that you have a look at chapter 6 of the lecture notes, and the particularly pages 8 to 11. Okay, now you don't have to so don't worry about this page, or you don't have to be busy taking photographs, because you're going to get these, you're going to get this set of answers later on. But let's go to chapter 6 and have a look. Chapter 6. So here, and I said that you should have a look at pages, especially pages from page 8 to page 11. So we'll go there. I'm referring to this one. Now, this is what's called a quadratic utility function. Now, my first message to you is this is not physics, and this may not be the only utility function that works, but this equation will describe fairly accurately these sets of curves, and you can see there is a parameter in the previous page called A, and the E is the expected return, so that doesn't really change for any given portfolio, and sigma doesn't really change, but A, the risk aversion, A for aversion, it depends on the individual, and different individuals will have different numbers for A. And as you can see, when A has a higher value than this set of curves, they go up much more rapidly. So a higher value for A implies a higher sensitivity, basically, for risk, okay, compared to when A is equal to 2. So having said that, I think, did Professor Fong mention, by the way, did he mention yesterday that, okay, I'm going to unmute you guys so that you can tell me. Okay, unmute. Okay, I've unmuted you guys. Tell me, did Professor Fong mention yesterday that in the final exam, you are allowed to bring in one piece of A4 paper he called a cheat sheet? Did you? Yeah. Do you like that idea? I like it, but there's one thing I don't like. I don't like to call it cheat sheet. No one cheats here. Okay, for me, it is one page of reference notes. A4 paper you can write on both sides. Now, okay, I'm going to mute you guys again. I think this would be a good example of what can go into a cheat sheet. So you don't have to worry about remembering, but you have to know it and you have to be able to apply it. Now, how do you apply it? Okay, so this is page 8. So page 9 is just the graph of that quadratic function, utility function. and then it's just this is just how it relates to when you actually have some real actual portfolio risk and returns in the form of a straight line. Okay, and then now this page is important, so this might go into your cheat sheet. I'm sorry, reference notes. I don't like that word. Uh, so at all times, basically, if this is your utility, uh, given the individual parameter for A, which is different from for one individual to the next. So what you do is you want to try and maximize that, um, and how you maximize that would depend on what parameter for Y that you have. Now, what is Y? Y is the portion of the portfolio that you would actually give to the active assets, to in this case the market portfolio. Okay, so the other part will be actually in cash, and um, what we are doing here is we are just substituting. Uh, so you get a linear combination of the returns and then the risk. So you just replace this by, so if y is equal to 1, okay, if it is equal to 1, then the risk that you are taking would be the same sigma of the portfolio. But when your investment is let's say 80% or 60%, then your portfolio variance will come down. Okay, and also your portfolio return as well. Okay, it will depend on Y, and then you just differentiate the utility with respect to Y. Now this is high school calculus, and then when you differentiate with respect to Y, this is the end result, and as you know, the maximum is reached when this differential is equal to 0. It's called the stationary point. And then, so when you rearrange this equation here, you will get the one below. And this equation becomes 0 when y is actually this quantity here. Okay, so that is, I'm just repeating basically what Professor Fong mentioned in class. This is how you derive this thing. Okay. Now, if we go back and we now look at the answer, and that is precisely what they are doing. Okay, so you are maximizing the utility, but I wanted to explain where this came about and why is this the condition that you need, and that's why I went over and I referred to Professor Fong's notes. But in the end, so okay, to put it simply, if I was a student, I probably would want to have oh, I probably would want to have this page. I'm teaching you how to take the exam, and maybe this one together with the answers, which starts here. So this is just a differential, and this is the, well, in fact, this appeared in the lecture notes. Okay. So what you can see is, so you solve for y, and the reason, okay, is worth mentioning in the question. they're asking, oh, hold on. The question is, what is the range of risk aversion? Now, normally that if a client just wants to be completely, what the term is fully invested, okay, fully invested. So not leverage, just $100. If they want to be fully invested, there should not be a range of risk aversion parameters. The reason why do we have a range here? Why is that? Why do we have a range? Do you think? Oh, hold on. Okay. Can anyone guess why we have a range? Okay, maybe it's not obvious. Now, the reason that we have a range is that is because of the difference between the lending and the borrowing rate. And if that was not the case, if you actually have a straight line, the capital market line, and then this is the market portfolio, then you have all these indifference curves, and then somebody else would be like this, and somebody else would be like, I should draw this all in different colors. There should just be one that is touching this one, and there will be a particular A value for that. Now, the problem here that we now have is the capital market line, it actually changes direction. So you have people who are very risk averse and people who are not so risk averse and so on. And then finally you get to here. But there are other, sorry, I didn't draw the last one very well. There are other individuals with different risk aversion. So this, in other words, because the line is now diverted or changing direction, at this point, there will be a number of different indifference curves with different A values that are capable of touching it. That is why you have a range. Okay, so I want to just point that out to you. And then to solve for that, in fact, you can see from the answer, because at one end, when you try to look for, this is the turning point. Okay, this is how you find a turning point. At one end, you actually use the value 0.05. Now, this is the risk-free rate for lending. At the other end, you do the same thing, but now you're using 0.9. That, ladies and gentlemen, is why you have a range between 0.64 and 1.28. Is everyone okay with that? So that's the answer. Okay. If it takes you a little time to digest all this, don't worry. You can either, first of all, you're going to have two things in addition today. One is the answers. The other is this video that you can look at. Okay? Everyone is okay? Are you guys still there? All right. Now, following that, so that's question 24. And 25 is asking you to solve for 23 and 24, but using your own fund instead of an index fund. So let's take a look at that. Now the index fund, so this is the one before the capital market line. The CML and the CAL, the difference is the CML refers to just the market portfolio, but the CAL is something that you constructed yourself. Okay, but they both are lines that you would draw in a graph connecting standard deviation and expected return. Now, because we already did that in the previous question, now it becomes a lot easier. But notice that your fund, like I said, although it has a lower expected, it has a lower expected return. It also has a lower risk. Is that supposed to be 11%? I think it has a lower risk. So therefore, if you consider this area here, your fund is actually adding some value. It is superior compared to the market portfolio. So that should be quite obvious. And likewise, a client would be happy to invest in your fund, fully invested, if they have a certain risk aversion parameter. But if they are very, very risk averse, then they will be over on around here. Whereas if they are less risk averse, they will be happy to invest in this direction, following this line. Okay. And then these are the attendant calculations. So these actually, they follow exactly the same logic of this page here. Okay, it's just your parameters are now different. You are not using 13 and 5 and 25 anymore. 5 you are still using, but not 13 and 25. You're using 11 and 15. I think this is supposed to be 11, but when I'm drawing it, it doesn't, I don't know if it, okay, never mind. And then, yes, you're using 11 for your portfolio and then 15. And then if you are borrowing, then obviously you borrow at 9%. So you get a different range. Okay. I don't know what is in the final, but I can well imagine a question like that being part of the exam in one form or another. I'm not giving you a tip. I have no idea, but just as someone who is also, a student in finance. Okay. Okay, hold on. Is everyone okay with that? Do you want to ask me any questions? Everyone is okay? Yes. Sure, tell me. This is Xiaolong. Okay, yeah, go ahead. Yeah. Hmm. The range of the slope of the curve. So what are you differentiating with respect to what? You are differentiating du by what? Okay, now hold on. Hmm. So you're differentiating du by d de e of what? Uh, by d sigma square, d sigma. Uh, okay. Yeah, 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 yeah. Um, if you differentiate de by d sigma, and then what? And then what are you trying to solve for? Yeah. Ah, okay. Oh yeah, yeah. That's yeah. I haven't thought about it that way. Okay, that's very good. Yeah, you can also similarly get the answer doing that. Yeah, that's fantastic. Actually, I'm very impressed, Xiaolong. Actually, no one else has ever mentioned this, has suggested to do it this way. Well done. Um, now, let me, uh, okay, it's now 10 o'clock. I want to at least cover also question 26, which is what is the largest percentage fee that a client who is currently lending will be willing to pay to invest in your fund? And what is a client who's borrowing? What about a client who's borrowing? So why when y is bigger than one? Now this is quite an interesting question, and I guess it has some reflection on reality. Um, so the for somebody who uh, is only happy to lend money, so previously we said that the setup for the risk aversion parameter should be okay. I'll show you. It should be like this, but now that if you are running your own fund and you're going to charge uh, some fees on that, you actually need to add an extra parameter, and they call it F, and that is going to hurt your performance. So you end up you are trying to investigate a relationship like this, and if F reaches a certain value, basically they will not invest in you anymore. Okay, so this is what you are solving for. Um, and it turns out that, excuse me, when a client is lending money, the maximum F that they will tolerate um, is 1.2%. The reason being, if this is your portfolio, okay, and if this is the market portfolio, then the numerator here is the excess return, and then down there is the risk. So if you start charging them fees, that means that this line here, this one, the more fees you charge, it's gonna start rotating clockwise. It will come down because of the fee you're charging. So at some point in time, your risk return trade-off will simply be the same as the market risk and return trade-off, and they simply won't invest in your portfolio. And that point actually is reached when your fee is 1.2%. That would be when actually this is a Sharpe ratio, isn't it? When your Sharpe ratio is the same as the market. They call it in the answer. Okay, let me just read that. The maximum feasible fee depends on the reward to variability ratio. I don't know why they don't just say Sharpe ratio, because that's what it is. And then if someone, so for a client who only will lend money, yes, you would use the 5% risk-free rate. But if a client actually is happy to borrow money and leverage, then the relationship that you need to examine is the one at the bottom here. So you're looking at 11% minus 9%, because that is the so-called risk-free rate when you borrow. And then there is another F to take into account. And F in this case actually becomes negative, which means that the client is not going to invest in your fund unless you actually pay them to do so. Okay. All right. So that is the rationale for this question. I think I will just leave chapter 7 for next time. So just to conclude, I want to remind you of a number of things, because we were scheduled for, okay, I'm going to unmute people now to make sure that you can give me feedback if you want to. Just a couple of things. So first of all, I would like to remind you, so quite important, a couple of things. So the assignment answers are posted in this file, number one. And then I'd like to remind you, today I have recorded this tutorial, and I'm going to put it here. And if you want to review last week's lecture, there is a video in Blackboard for October 5th. There is also a video for the tutorial, the electronic tutorial of last week. I would like to remind you to vote for how you would like to do the tutorials going forward. And there are three choices. So either Saturday for 45 minutes or Sunday morning. And I think if I was to ask you to come in on Sunday morning, I should give you more time, okay? Or we can do it the way we are doing now, but perhaps later for an hour and a half on Sunday morning. So you just scan this QR code and you let me know, okay? Can you please let me know by, let's say, end of Wednesday this week, so I can then organize the logistics. Is everyone okay with that? Yeah, thank you. And then further to that is, so not next week, the week after, on October 26th, the two teams who are presenting will be a Teacup in Storm and Diamonds Are Forever. And if you can kindly just click on this link, it will take you to a Google Sheet and just enter the price of your stock as of the close of business on Friday, last Friday, just 2 days ago. I would really appreciate that if you can do it. And I will load up this tutorial file to Blackboard. I don't think I've done it yet, but I'll put it up there so you within an hour you'll see it. Okay. The question is, not all the shade where my CA is superior to CMO will attract clients. When client wants to borrow, client won't buy my fund even with no fee. No, okay. So for question 26, the problem with this is that you are charging a fee. Oh no, hold on. Client won't buy my fund even with no fee. Hold on. The reason they won't, okay, hold on a second. Let me, I want to just wipe out some of this stuff. The reason the client in this case, now you can see that, okay, let's talk about your own, if you are the portfolio manager, this portfolio, the problem is here you have a higher Sharpe ratio compared to this one. So when I said that this area is superior, is when your fund is superior, I guess actually from a risk adjusted point of view is only up to here. Okay, the moment you are in this area, this line here is actually flat compared to, I don't know if you understand what this line here is flat compared to this one. Okay, if I was to draw it, let's say if I can magnify it. So you have, this is the market, this is the market portfolio or the index portfolio, and then your own fund. So because we are now looking at it from a risk adjusted point of view, so here you are superior. I think it goes something like this. Oh, too flat. So this part, your portfolio will be, your own fund will be superior, and the more fees you charge, it will bring this line down. It will bring this line down until at some point in time you have the same risk adjusted return as the market. Now, whereas for someone who likes to borrow, you are now looking at this segment here, and this segment is actually inferior to this one unless you actually pay them. Now, if you pay them, what happens? If you pay them, it's going to end up lifting this line up in the counterclockwise direction. So the risk-adjusted return will start rising when you pay. Of course, you won't pay them unless you're out of your mind. Is that okay? So who asked this question? Hold on. Was it It's Zilu, right? Is that okay with you now? Do you understand what I just said? Yes, because there's a triangle shade where my CAL is higher than CML, so client should buy my fund in any part of. Oh, oh, I see. Thank you, Sam. So are you okay? Are you okay with that now? Is Zilu okay? Zilu is there? Yeah, yes, I understand now. Sorry, there are some issues in my mind. Okay, no problem. Um, yeah, so I think I'm gonna let you go now, and I want to thank you for coming. And if you want to have another go at the homework, I would be happy to have a look at it. Even though I've already gone through the answers with you, no problem. If you want to just close the books, write down the formulas, and do it yourself, fine. I'll take a look at it, and I will register your effort as well. Okay. Um, are there any more questions from anyone regarding the questions or any other admin stuff or good question. Yes. Now, because I'm not in Hong Kong next week, so thank you for asking. So normally I put that at the end of the tutorial file. So you can have a go at these questions. But like I said, you have 2 weeks. So some of this material, I think Professor Fong will likely cover um, next Saturday. Okay. Have a go and don't worry if you can't do it because we're going to go through all of them and then we will provide answers to them as well. Okay. You've been a great audience and I thank you so much for your understanding and your accommodation. Okay, I really do appreciate it. Have a good day, everyone, and I look forward to seeing you again soon. Okay. Anyone else has a question? Is there lecture quiz next week? Ah, no, no more. In fact, uh, what Professor Fong will do is, or has done, is he will quiz you in the lecture 2 times. So there are 2 lecture quiz, and he asked me actually to quiz you in a tutorial also 2 times. And out of these 4 quizzes, we will take the best 3. So even if you were absent in one of them, it's not really a problem. Now, before you get stressed out, okay, don't worry about the tutorial quiz. I'll give you plenty of advance warning, and I'll try to make it suitable, which is to say, not very easy and not very hard. Okay, but don't worry about that for now. But I think since we are going to have some tutorial quiz, I think at some point we will have to meet in a classroom. We can't keep meeting like this. Just keep that in mind. So two of these remaining meetings will have to be in a classroom actually. So it's a good point. Thank you for asking that. It's Zhang Ting. I thank you for asking. Yeah. All right. Enjoy your Sunday, and I wish you a very restful remaining weekend. Okay. Thank you, everyone, and see you again soon. Thank you.